Uh, Howdy. Welcome to CS 410, Advanced Functional Programming, the module in the department where no one who has ever taught it has ever stopped. So welcome to the most ridiculous staff-student ratio you're likely to encounter. Guillaume's running the show. We're the old farts. Do you want a mic?
Well, do you want to start?
Because... Can I say something? Yeah. So maybe we should introduce ourselves just in case. So yes. Connor is Connor, Guillaume is Guillaume, and I'm Fred. And we also have Sean Waters who's going to help you in the labs. So that's the team. And as Connor hinted, we didn't think Guillaume could make it today, but we're happy he could. So see how this goes. Guillaume?
Yeah, so I mean, we're not planning to do any admin today. We just have the lectures, right, which are today and tomorrow, so a good way to start the week. And then a bunch of labs. There are still constraints to be solved, so we don't know exactly when they will happen. There will be labs today immediately after the lecture, if I remember correctly, just to help you install Agda. What we're aiming for, given the coursework and so on, is the latest released version of Agda, together with the latest released version of the standard library. So if you already have something installed, but that's a bit older, you might need to upgrade because we will maybe be using new features in the coursework. Talking about the coursework, all the assessment is through coursework only. There will be 2 courseworks, and you'll have a few weeks to solve both of them. The first one is a bit shorter than the second one, so the first one amounts for like 40% of your final grade, and the second one will do the other 60%. So you have complete autonomy. You can go to the labs to get help if you get stuck or need something re-explained. We reserve the right to ask you to come in and explain your solution if we think it's necessary. Otherwise, yeah, just submitted after the weeks. What else is there? Oh, we're aiming to follow the university policies in terms of grades. So the first 40 should be fairly easy to get. Then you can get to 60, 70 by doing everything we ask you to do really competently. And then going beyond that, you need to demonstrate mastery, even maybe do something completely out of the ordinary. So that's why the coursework will typically start with some easy questions. Then we sort of build a project, which should be fun, hopefully. And then there's sort of an open-ended question at the end. You can just do whatever you want to extend the start of a project we gave you and do something interesting with it. And as you'll see in this lecture, something interesting typically means some interesting modelization using types, and some clean implementation using a lot of auxiliary definitions that are well thought out and composed together to get a big result. So we don't want to see spaghetti codes. Most of the functions will be fairly short, but also fairly powerful. Did you want to move on to?
Yeah, right. So maybe that was most of the details today already, but maybe we'll stay a little bit more tomorrow. So in terms of attending the lectures, of course, we hope that you will all come here because it's more fun to talk to you rather than to an empty room. But if you for some reason can't make it and so on, we try to make it so that that's not lethal for you. So we'll put the results, so you can see that we have a little file we're working in. So most of the lectures are going to be just live programming. So we'll put these files probably before the lecture and after the lecture, so you can compare what we did. We put this on GitHub. I think we're going to make another repository, right?
Yeah.
Where the coursework will also live, so you can just clone that when you want to work and make your copy of the coursework. So put that on GitHub so you can look at that again. You'll notice that we're wearing microphones so that we can record this. So we'll put this probably on YouTube, I guess, but link it from somewhere. So that you can come back. So especially when you're doing the coursework, there could be some concept that you need for the coursework, but you didn't realize you needed it in the lecture. So maybe you weren't paying attention or you weren't ready to understand that yet. Then we think it's a good idea that you can go back to the video and just re-watch that segment.
Yeah, it was as long ago as 2017, our students said, could you please video the lectures? Because it's only when we're in the middle of doing the coursework that we realized something you did was terribly important. And now that we've got context for it, we could go back and watch that, and it would actually connect better than it did at the time. So that's a service we have tried to provide since then.
So that's why we do that. And we try to put this up immediately after the lecture, basically. We also have some 1-minute papers that we would love for you to fill out. So I just pass these around. They should take, as the name suggests, 1 minute to fill in. So the idea is that you just tell us what you thought of the lecture and what you're confused about, what you would like to know more about, and so on. And then we look at it after the lecture, and we might then adapt the next lecture or quickly respond to questions at the beginning of the next lecture. And we'll also use these to take attendance. So that we don't have to do a separate attendance. Okay.
So you're probably already familiar with 1-minute papers from first year, and this is just a gentle reminder that not all questions are really good for 1-minute papers. So if it's a deep question about something you didn't understand, maybe it's better to interrupt during the lecture so that you get a second explanation. There's 3 of us, so there should be at least 2 explanations among the 3 of us available. So don't hesitate to interrupt us. That's the main point of a live lecture, right?
You have to guess which one of us always lied.
Right. I should also say, so this 1-minute paper is our generic template. I'm not sure if you remember the 3 little words you had in first year. You don't need to worry about that. Just put your name under the name column, and then we'll figure it out from there. The lecture column is for you to make up the most fun name for the lecture you can think of. Sounds encouraged. Okay, anything else? Oh.
Mattermost, maybe?
Yes. Not have this? No. Yep. Do you want to talk about Mattermost?
Sure. So if you need help, you can go to the labs, but that's only once per week or maybe twice. We have up to 3 hours of labs available, right? But our experience from last year is that no one shows up, and then we just all waste our time attending the labs. So we'll only start running 1 hour of labs, and then if there's a lot of demand, we can just expand from there. But if you have a question, you don't need to wait 1 week until the next lab. You can also ask it on the Mattermost, and then either one of us or one of you will be able to answer it, and you'll hopefully make progress.
Okay, are there any questions at this point?
Page for the class is not actually open.
Yes.
Intentional.
Yes and no. It's not open because it's not ready. But
Fair enough.
Since Guillaume is responsible for this, I can promise that this will be fixed by tomorrow.
Essentially minimal compliance, right? Just going to have the data repository where everything will actually
be. Yeah.
Right. And some details again about what the assessment is and so on. Okay, should we then actually start with some content? Who wants to do this? We start?
Well, get a mic if you're going to start.
Oh, it's all right. Okay. We've got an empty file. Aha, right. Okay. So the designers of Agda helpfully made it almost but not entirely unlike Haskell. So we're going to start with some material which is hopefully reasonably familiar conceptually, so that we can just show you the subtle difference in notation. So.
Connor, did we actually say what this class is about?
Well, it's about programming in a functional programming language except it's one where you tell the truth. So I don't know. Shall I do the traditional joke at this point? Right. So if you type Brexit equals Brexit into Haskell, it will tell you that Brexit has type alpha. Well, that's to say that Brexit will give you anything you want. And then if you run it, you will discover that it takes a very long time, because Brexit equals Brexit as a definition makes no sense whatsoever. If you type Brexit equals Brexit into Agda, it goes a funny color and says termination checking failed for the following functions. Brexit problematic calls Brexit. That's to say, what it's saying is, that's utter nonsense, take it away. Yes. But fortunately, there are some programs which do make sense. And this is really the high-level scheme, is that we're trying to facilitate you to make more of the sense that you think your program should be making to the computer, right? A lot of the time, we just tell the computer what to do, and we tell each other why. If we're lucky, we might write it down in some documentation or some comments or whatever it happens to be. But we don't often get to give all that much of the explanation to the computer itself about what it is we think we're achieving. And there's a lot of room to improve that situation. So we are working with a language that has a very expressive type system, where the deal is you're kept honest by the type checker, but because the language is so much richer, you have enough flex to actually tell the truth. So it's a whole new deal in terms of how you use type systems in programming. Is that, that's the deal is that in order to require that level of honesty, we have to actually give you enough language to explain yourself. Okay, but let's start with something familiar from Haskell. Lots of Haskell programs get written using lists. So let's invent lists. And I'm probably going to get in trouble with the standard library people for... but you can do a search and replace on whatever ASCII art I choose. Right, so I'm going to make a data declaration, which is quite a lot like what you would get in Haskell, but with slightly different layout. I'm going to declare a type constructor called list, and I'm going to say it takes a parameter x in set. Set with a capital S is Haskell is Agda's type of types. Actually, it's Agda's type of boring types. We'll get back to that eventually, I'm sure. So actually, I can even load that already. Things go on amusing color. But, I typed Control-C, Control-L. That's a very important point. Actually, sometimes we even put a camera so you can watch our fingers as we do this stuff. But it's important to say that the other thing that happens is that Agda programming is very interactive. So we're working in this Emacs mode. There's an information panel. There's some source code here. We tend to work a little bit at a time. Okay.
Yes, so let me repeat that. Agda programming is very interactive, so it's a bad idea not to install the compiler and just write code blindly. Some people have tried last year. It didn't end well. So if it's hard to install, etc., that's understandable, but please get help. And do use the compiler to have a dialogue whilst you're building your programs, as we'll see today,
yes.
Because it's a lot of help.
expectation management. Agda is very often difficult to install and quite sensitive to variations in your setup. So our objective for this morning's lab session is simply that you finish it with the thing working on your computer. Right. Nothing more than that, right? Victory is installation. Okay, so here I've said that if X is a set, then list X is a set. There are no funny capitalization conventions in Agda compared to Haskell. Remember in Haskell, capital letters were for constructors and lowercase letters were for functions and variables. Here we got no such convention. So all identifiers are up for grabs. Our habits are to use capital letters for things that are type, type sorts of things. So I'm using a capital X as a variable that stands for the element type in these lists, and capital L for list. Okay, but I haven't said what the values are in list X yet. So
let me interject for another boring syntax. So notice that the has type symbol is 1 colon rather than 2 colons, like
yes.
in Haskell.
Yes. The designers of Haskell thought people wouldn't write types very much, and that they would do an awful lot of stuff with lists. So they thought 1 colon for cons, 2 colons for types. Somebody recently did the experiment of just replacing all the types in Haskell, in the Haskell repository, in the kind of central code repository, replacing 2 colons for typing with 1 colon and 1 colon for cons with 2 colons, and the repository got 10% smaller. So the Haskell people were just wrong in the first place. Right, so I'm working a little bit at a time. Okay, so I've Agda also has some quite interesting choices about spacing and symbols. Basically, pretty much all the characters you can think of are up for grabs. If you want to see when one lexical token stops and another one starts, for the most part, you put some space in. There's a few exceptions, such as for parentheses, which are allowed to touch the things that they include. But basically, it's very simple, lots of space in Agda programming. All right, so I have said, so this is just an ordinary identifier. The fact that it looks like a pair of square brackets is just meant to be suggestive. This is just one symbol. Okay, I'm going to, so I've said nil is a list with elements drawn from X, and I'm going to say, I'm going to use my favorite, and you can bottle me off later. And again, I will save the file and do Control-C, Control-L to load it. Right. So you'll notice a few things. First of all, when you load the file like this, Agda colors it in. And that's not syntax highlighting. That's actually after an interaction with the type checker. And it has figured out that this list is making types, so it's colored blue. And whereas these things here, this empty square brackets and this comma minus that I chose are green because they make values. So there's everything's color coded, and that color is supplied by the type checker. Okay, so what am I saying? Also learn to read this. This thing here, these underscores are special. What I'm saying here is that comma minus is an infix operator. The underscores tell you where the stuff, where the values slot in. Okay, so I'm saying that this thing, which is my notation for list cons, takes an element of X and a list of X's, so a head and a tail, and makes another list of X's. So this is lists as you know and love them, but with slightly different symbols from Haskell. Okay. Do you want to write a program?
Well, with that keyboard layout, I won't be able to. It will just be a painfulness.
Yes.
I'll just say something about the identifiers. So in Agda, you're not limited to having infix operators. You can have operators that say take 10 arguments, and all of them will be in between bits of the identifier. What matters is that there's always some concrete looking name in between the different holes, but you can have just as many holes as you want. So if you want to write if then else, for instance, in fact, that's just a normal definition. And as long as you're using the underscores to tell Agda where the values will slot in, you can just do whatever you want, which is dangerous, but also really good.
Okay, should we try and write the append function? What should we, yeah, maybe I'll just call it append like this. Okay, so I want to write a function. So as in Haskell, I start by writing a type signature for my function. So I give a name, then I write a has type symbol, which is 1 colon Agda, and then I give the type. And so what I want to append to do, I want to take two lists and append them together, right? So this should take a list X and a list X and give me a list X. So I guess this is what you would write in Haskell, and then Haskell will figure out that this X must be a type variable, and you will be happy. But here in Agda, because our types are more interesting, we have to be more precise about what occurs in our types. So I have to explicitly say that X is a set. Except it's kind of boring to give this explicitly. So Agda has special syntax for implicit arguments, which are these curly braces rather than the round braces. So what that means is that we don't have to give this argument explicitly. It's figured out implicitly by Agda what this has to be. Because if I give this function a list X, then you can figure out that X must be a set, because that's what it was declared to be up here in the data declaration, right? So Agda is doing more work for us, so that we don't have to mention the boring arguments to a function, for example. Okay, so then what I typically do, so I've written the type signature, and then what I do is I say append equals question mark, because I don't know what this is yet, and I'm going to build this up slowly piece by piece. So I just say, I don't know what it is, it's a question mark, and then I load the file, Control-C, Control-L for loading. So what happened here was that the question mark turned into a goal or a hole or a shed, whatever you want to call it, which is a place where we can interact with Agda, right? So we haven't solved this problem yet. We haven't defined append. We still have this goal 0 to fill in. And down here, I'll make this a bit bigger. We can see the type of the hole, right? And because I just said that the right-hand side is a question mark, the type here is the same as the type I gave to the whole function. Except you see that this X has actually been implicitly given already. So I can also go into the goal and I can interact with it. So I can ask, what is the type here and what do I have available? That's Control-C, Control, comma. So it tells me the type of the goal, and it tells me everything I have available, which in this case is just that X is a set, but that's an implicit argument, so it's not in scope. So next, yep.
You might have seen holes already in Haskell, so you could leave part of the definition out, and as long as the identifier was starting with underscore, you get 3 pages of output telling you what the type of the hole was and what was in the context. Here it's just very compact, and you don't have to go fish for that information among like the rest of the outputs of the compiler. You can directly inquire about it. And as we're going to see very soon, you can also interact with it.
Okay, so I know that my goal is a function type, right? So I'm trying to avoid thinking for as long as possible. So if it's a function type, then I know that I better introduce some arguments here on the left-hand side, right, that I want to apply my function to. So I just call this one x's and this one y's.
So you could case split.
I could case split. Okay, so I go to the goal and I do Control-C, Control-C, and split on the result. Is that what I want? Yeah. So I ask Agda to fill this in for me, but unfortunately then Agda has chosen some really terrible names here, right? So the first argument is called x, and the second is called x1, because x was not available anymore, I guess. So I'm actually going to rename this to something I like. Okay, and then after I've now changed things here, then Agda doesn't know what I've done yet, right? So this is running in Emacs, a text editor, and you have to explicitly send things to Agda so that it knows what you've done. So Agda still thinks that this variable is called x and this is x1. So whenever I do any change, I have to remember to load the file again, Control-C, Control-L, right? And now Agda is up to date with it done. So if I go to the goal again and I see what do I have available, Control-C, Control, comma.
VS Code also, or?
It might save automatically more often.
I think it might do it automatically in VS Code, which be extremely slow if you have a complex program. Might be helpful for this.
Okay, so now we see that we have a little bit more interesting things here, right? So we still have the set x, but we now have access to a list x's and a list y's, right? Which we have introduced here on the left-hand side. And our goal now is to just produce a list. Right? And of course, there's many ways we could do this. We could return the empty list. We could return the first list. We could return the second list. But in our minds, we know that we want this function to actually append the lists, right? So how do we do that? What do we return here? Well, it really depends on the inputs, right? So for example, if this list is empty, then we should just return the second list. If it's not empty, then we want the first element of the output to be the first element of this first list, right? Because I want to append them together. So I think I better look at the first list. And Agda has special support with this, so I can do a case split on a variable. So do Control-C, Control-C for case. And then, I'm not sure, it's a bit small, but you can see down here, it's asking which variable do you want to case on. And in this case, I want to case on x's. So I'll type in x's, press enter, and I get my two cases for x's. And then I can, so now I have two goals. I have goal 0 and I have goal 1. And I can look what I need to do in these ones. Well, in this one, I have to produce a list. And I have a list. And in my head, I have this idea that I want to append two things. So if I append the empty list with something else, I should get something else. Right? So I type in y's. And then I do Control-C, Control-space to give this as the result of filling the goal. Right. And then because I don't trust myself, I reload the file just in case. It's all fine still. Okay, so then now here I have one goal left. And what do I want this to be? Well, I know that I want it to start with x, right? So I know that it should start with a cons. So what I typically do, I do this in small steps. So say this is going to be something cons something. So I put question marks, but I don't know where to put things yet. And then I can give that Control-C, Control-space. And then again, I have these two goals now, right? So I have goal 1, where I have to give an element of x. And I have goal 2, where I have to give a list. Okay, so I can look at goal 1. Okay, I have to produce an x, and I have all of this available. Well, here there really is only one thing I can do, right? I suppose I could now split on y, so do something silly, but given this information, there's only one way I can actually produce an x, and that's to give this x. So actually, I could ask Agda to try to find a solution for me. If I do Control-C, Control-A for auto, it will go and search for something to put in this hole. And because there's only one solution and it's very easy to find, then Agda succeeded in this case, right? Okay, and then I can look here. And again, I could try to do an auto, Control-C, Control-A. But that's then, it's finding something that fits the hole, right? But that's not the answer I wanted. So don't blindly think that auto is going to solve all of your problems, right? So what do I want to do here? Well, I've produced the first element of my output list, it's x. And now really I want to keep appending these things, right? So I want this to be a recursive call, append x's, y's. Okay, and then maybe I don't quite trust myself. Does this fit in the hole or not? I could just give it and hope I don't get an error. But I could also ask Agda, what is the type of this thing? So I do Control-C, Control full stop instead. And then I get the goal I have and the type of the thing I have typed into the hole. So I have something which is a list, and I want something which is a list. So that seems to fit, right? So I can then go Control-C, Control space to fill it in. And then I load it again just in case. And Agda says that this is checked, and we are all happy, right? So this is typically how you write a function. You just do it in very small steps. You don't try to just get inspiration and type all of this in at once and hope you get it all right, right? You try to get help when you can get help.
You are keeping a dog. Do not bark yourself.
Do you want to write the zip function?
Yeah, I kind of do. Let's see what we got. Okay. So, I need pairs. Maybe I won't sit with.
Yeah.
Okay. Okay, so that Pascal library function, I don't know if it's particularly familiar. Actually, no, I will write a function which is a friend of zip, sometimes called zap. And its types as, suppose S and T are both sets. If you give me a list of functions and a list of inputs for those functions, then I will give you a list of outputs. And the idea is that we're going to apply the first function to the first input, the second function to the second input, and pair them up, and do all the applications in parallel. Okay? So I've got my two lists. They're F's and S's. Right. Let's load. See what we've got. S and T are sets. We've got a list of functions. We've got a list of inputs. We're being asked for a list of outputs. Okay. So we know if we want to pair up the first function with the first input, then we're going to have to take both of these lists apart. So what you can do is you can type the names of both variables, F's and S's, into the goal and do Control-C, Control-C, and a whole bunch of work happens at once. It splits those two inputs into the four possibilities you might encounter. And then, of course, it chooses the most truly dreadful names for everything. So I will fix up the names and reload. This keeps happening. You can sometimes get somewhere if you actually choose to give the names in the data declaration. Then it will pick up the names you gave and use that by default. It's still not always helpful. I never taught them the trick, but I might do it properly anyway. Okay, so two of these cases we like. Interesting question, by the way. Okay, we've got no functions coming in. We got no functions, no inputs coming in. So what outputs shall we give out? The empty list. Do we have a choice? This is one of the joys about kind of polymorphism, is that when ignorance is bliss, 'tis folly to be wise. The fact that we know nothing about S and T means there are very few places these outputs can come from, which is good news. Okay, so I'm going to do Control-C, Control-A. So basically, Agda has an auto facility, and doing Control-C, Control-A is a bit like going to Google and hitting, I feel lucky. I've basically just said, I'll take your first guess. Give me, I don't care. You figure something out. And I can do that here because I know there's actually only one possibility. Okay. Now, let's do the other case we like, which is when we've got a function and an input, and then some more of those things. Okay, so what I'm going to do is, what would happen if you actually just, the equivalent of actually just Googling it. I type -L in the hole, because that's a special option, and I do Control-C, Control-A. And Agda kindly prints out a list of things it's thought of.
It's sneaky because it's even suggesting things that will not terminate, right?
That's
or that it will complain about.
Yeah. Although amusingly, it hasn't suggested the one I wanted.
They're all getting small.
Yeah. So maybe I'll give it a clue. No. I want something cons something. Okay. Right. I want a tea. Can anyone see how to make a tea, given the equipment that we have available? Yes, you can. So can Agda. There was only one way to do that. And now I'll do my -L, Google it again. And this time I can see the thing I want. It's, I don't want the empty list. I want this one. So I say -S1, that means skip one, Control-C, Control-A. What? Do I have to put a space? And it fills it in for me. So that's, you can use auto to say, just think of a bunch of things that type check. Give us a menu. And then you can pick the solution that you like the look of most from the menu, if indeed you like any of them. Okay. Now, we're not done. We've got to figure out what to do in the awkward situation that we've got, that the lists are ragged, that they're not the same length. And in fact, well, do we have a choice?
We have a choice in how we implement it.
Yes.
We could make a recursive call when it's getting smaller and smaller.
Yes, it's true, but ultimately, in one case we've run out of functions, and in the other case we've run out of inputs. So there's no way we're ever going to be able to construct an output. So we actually have to give back, if we want to finish this job, we actually have to give back the empty list in both places. And Agda can figure that out perfectly well. So we're done, but perhaps we're not happy. In that, usually, if the lists don't turn out to have the same length, we've done something wrong. If they don't line up properly. And here we are giving back some kind of garbage value just to be able to say something. And that isn't even always possible. Indeed, there are actually some Haskell programmers, me included, who make sure that we redefine zip so that when the lists have the wrong length, the program crashes instead of giving back a garbage answer. Because it's much easier to find the problem if it just falls over than if a bogus value gets propagated somewhere else, contaminating goodness knows what. And indeed, once upon a time, I found exactly such a bug in a piece of software that was called Agda. Yeah, it was kind of, it was just the wrong two lists were being zipped together. Just a silly, used the wrong variable in the wrong place. And I think this was the first time either of the two lists had ever been non-empty. Well, that was kind of fun. So yeah, we're sitting here thinking, you know, we might like to make a better promise about the lengths of the lists than we have been able to so far. What time is it? It's 10 to nearly.
My suggestion is that we leave a cliffhanger, but let's see if we can do head and tail. Maybe it's okay to be a bit shitty, right?
Okay. So this is how it goes, basically, is that the older you are, the more likely you are to get the stooge job. So, okay, head and tail. Shall I do tail first?
Tail.
Tail. Okay. Roll X in sat. If you give me a list X, I'll give you a list X. Tail X is what? Right. Okay. Well, going to have to look at this list to see whether it's got a tail, and if so, what it is. So I'll say X's and do Control-C to split. And here, I can see that the head is X and the tail is X's, so I just want to give back X's. Now, here,
I know a trick from Haskell. Can we not just delete this line?
Oh. So what's happening here?
What did you do here? Cancel, I think. Oh, okay.
Did I just do something silly with that? Yes. Okay. Agda really has caught us out here, right? We're trying to get out of the rubbish case that we don't want to give. Agda's not having any of it. Right? So that's one of the new promises that Agda makes that Haskell doesn't make. It's like when you have a function with an input type and an output type, Agda promises on your behalf that if you put in an input of the input type, you will get out an output of the output type. I mean, seems reasonable, you know? Well, you know, sometimes think, oh, right, I've got to do something. Okay, so usual deal, we have to produce a list whose elements are drawn from this unknown type X. We have no values available of type X. Do we have a choice? We just have to say, oh, miserable, the tail of the empty list is the empty list. Well, that's a bit crap. Again, when that, you know, if this code ever runs, we've probably screwed up. Okay. So, moving swiftly on, let's try and write head. Okay, same situation. I split into two cases, and one case I like. Agda can figure that one out for me. Now, what's going on here? I have to give a value in the element type, and the only place I can possibly get such a value is from the input. However, the input is unfortunately empty. So at this point, we're completely hosed. I don't know if you've seen the movie Bedazzled, where Peter Cook plays the devil and Dudley Moore plays someone who gets granted 10 wishes by the devil, except that he has to word his wishes very carefully because they will be granted in some particularly pedantic and irritating way that he's not going to like. And he's been told that if he ever wants to give up on the situation he's in, he should just blow a raspberry. This is the situation. We're in the situation where Dudley Moore would be going, right, we just don't want to be in this situation where we're asked to deliver an element that cannot possibly exist. We're going to have to think, we're going to have to figure out how to get out of this trouble by not getting into it.
Right, and that's what we'll do in tomorrow's lecture.